Last section of chapter 2.8, two variable inequalities. In some situations, you need to compare quantities. You use inequalities for situations that involve these relationships. Less than or equal to, greater than, and greater than or equal to. Graphing an inequality in two variables is similar to graphing a line. The graph of the linear inequality contains all points on one side of the line and may or may not include the points on the line. And that's a key point here. May or may not, depending on what the symbol is. If it's an equal sign underneath it, it will. If it's not, it's not. A linear equality is an inequality in two variables whose graph is the region or coordinate plane bounded by the line. The line is the boundary of the graph, and the boundary separates the coordinate plane in two half planes. One would consist of the solutions of the inequality. So if I was looking at this one, here's my boundary lines, here's my shaded region. Okay, so now let's look at some problems. Well, first, to determine which half plane is shaded, we pick a test point that is not on the boundary. Check whether that point satisfies the inequality. If it does, shade that half of the plane that includes the test point. If not, shade the other half of the plane. The origin 0, 0 is usually the easiest test point. So we're going to graph these like we did before. So what I mean by that is, okay, let's just take this first one. And actually, I'm going to graph both of these on the same graph. Actually, no, I won't. Here's my first graph. Okay. Let's say here we get y is greater than or equal to this. My starting point, my y-intercept is 1. My slope is down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. And you should label these points. So if I was labeling this, down 2 over 1, this point here would be 1 and negative 1. This would be 2, negative 3. This point would be here 3, negative 5. And you should have 5 points. And this point here should be 0, 1. And you should have one more point. Now if I drew my graph here, now what kind of graph do I want? Well, this is an equal sign underneath here, so I want a solid line. So I'm going to draw my line right through those points as best I can. There's my line. Make sure I have arrows on both ends. So, and I have a solid line because there's an equal sign right here. Now we have to test it. Well, it doesn't go through 0, 0, so let's test 0, 0. When I say test it, we're going to plug it both 0 for y and 0 for x back into the equation. 0 greater than or equal to 2 times 0 is 0, plus 1 is 1. 0 is greater than 1. That's false. So I don't want this point, I want the other side, so my shaded region is going to be over here. Anywhere on that side at the points I want. Now this one, I'm going to extend it down a little bit more again. So to get small, now here we got y is less than negative 2x plus 1. Same, now if it's less than, I actually get to draw this in the same graph. But I'm just going to change it up a little bit. First of all, less than. Actually, I'll draw a new graph. What the heck? It won't take me long to do. My second one, B, still starts at 1 and goes down by 2. So we're going to do that graph. Starts at 1, goes down over 1. You should label your points again. But the graph difference here is the fact that this one doesn't have an equal sign. So this one is going to be a dotted line. Still has arrows on the end of it. Still has arrows, but it's going to be a dotted line through those points. So it would be the same points actually as we go through here. It would be 0, 1, 1 and negative 1, 2 and negative 3, 3 and negative 5, and so on line. So it would be dotted. But now it's less than. Now less than, try 0, 0. 0 is less than 1, and that's true. So we're going to shade on this side this time. We're looking at shading. Okay, so now it says use a linear inequality. The map shows the number of tickets needed for small or large rides at the fair. You do not want to spend more than $15 in tickets. How many small or large rides can you ride? Well, first of all, it's 25 cents a ticket. So if we have $15, I'm going to go by We can get 4 tickets for every dollar. We have $15, and each dollar we get 4 tickets. So we're going to get 60 tickets total. Large rides take 5 tickets. Small rides take 3. So let's say X is the small, Y is the large. So it's going to be every small ride be 3x plus every large ride is 5y has to be less than or equal to 60. Now if I graph this out, and I'm going to graph it out the best I can here. Oops, let me undo that. Forgot to change my shape of my line here. And I'm just going to go like this, because I don't really need negative numbers. Now another way to graph of this is using x and y intercepts. And I can get y by itself on here if I wanted to, and graph it that way. Another way is say if y was 0, that's right here, x would be 20. So I'm going to go out to 20 here. 5, 10, 15, 20. If x is 0, y would be 12, 2, 4, 6, 8, 10, 12. And if I drew the line between those two dots, I would have something that looks like that. Okay, so this one's going up by 2s. This one's going over by 5s. Now I might have to have a better scale on my graph as I go through, because I might have to say, okay, I can fit other 1 and 2, 1 and 1, 1 and 2. So it says, how many small or large rides can you ride? You're going to get a lot of options here. If I start writing them out here, I could say, okay, I can go 0 and 1 large ride, 0 small, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9, 0, 10, 0, 11, and 0, 12. I can go 0 small rides and up to 12 large rides. Or I can go the other way. Or I can go, okay, I'm going to take 10 small rides and 4 large rides would work too. So there's a lot of options being in here. So you could pick any point in here. Now, the thing you have to realize is the graph I was shading says less than or equal to 60 would be down here. Well, if I was doing a realistic domain, it's only this area in here, because it can't have negative rides. And also, if I was doing a realistic domain, is that the points would only be solid points. You can't have fractions. I can't go on 2.5 rides. It would only be the whole numbers as you go through this graph. So now it says here, suppose you decide to spend $30 in tickets. What are the possible combinations of small and large rides that you can ride now? Use a graph to find your solutions. Now, the only thing now is you got $30 instead of 60 tickets we can buy 120. So your equation is not going to change a lot. So you're going to have 3x plus 5y is less than or equal to 120 now. If I was graphing it out, that was a little slanted there. Let me draw that over. So now I can go over to 40 here. So if I was going over 2, 3, 4, I'm going to say 40 here, and this would be 24 here. So 3, 9, 12, 8, 15, 18, 21, 24 there. So if I drew my graph in there, still shading, so it's going to be in here in any combination. So I can say, okay, 1 in 20, 1 in 15. So there's a lot of different numbers I can use. Now it says, okay, why did the graph of the solution problem 2 only include quadrant 1? Because I can't have negative tickets. If x stands for the small number of rides and y stands for the large number of rides, you can't have negative rides as you go through. Now we're going to graph the absolute value inequality. Now what we're going to do here is we're going to try to get y by itself. So let's say I just subtract 1 from both sides here. We're just going to try to get y by itself. So we have negative y is less than absolute value of x plus 2 minus 1. Divide everything by negative 1. So we get y. Now notice I'm going to change the signs. It's greater than a negative x plus 2 plus 1. Now if I was graphing this equation, what happens? Okay, let's think about our transformations before. Our transformations before, it says this part is going to move my graph, and that's going to move it 2 units to the left, and this is going to move my vertex 1 unit up, so right here. So I'm going to start my graph here. Now this is going to take a negative, so I'm going to go down, and my slope is 1, so down 1 over 1. So to get some points, down 1 over 1, down 1 over 1, and I'm going to go both ways. So my graph is going to look like that. Now this is a greater than symbol, no equal, so it's a dotted line. So I'm going to put my dotted line in here. So there's my dotted line. So my graph looks something like that, but now I have an inequality. We hit the test value. Let's try the test value of 0, 0. Since this graph does not go through that point, let's try test value 0, 0. 0. And I always go back and test it in the original equation. 1 minus 0 is less than 0 plus 2 is 2. So 1 is less than 2. And that's true. So therefore I want to shade where that is. So I'm going to shade out here all the ways around. Okay. Let's try one more. Kind of same setup. Oops. Get y minus, I'm going to add 4 to first of all to both sides. So we're going to have y is greater than or equal to 2 times x minus 1 absolute value plus 4. Now if I was graphing it, I would go like, oops, wrong graph. Okay, there's my graph. My starting point would change. Now I'm going to go over to 1, up 4. Okay, my slope is 2, so I'm going to go up 2 over 1. I would label my points now. I'm not labeling because I don't have a lot of room to label on my graphs, but I would expect you to label. So if I was labeling this point, I would go over 1, up 4, so it would be 1, 4 here. Up 2 over 1, so it would be 2, 6 there. Up 2 over 1 be 3, 8 there. And so on down the line. And this side would be up 2 over 1. There's a point I should have right there, which would be 0, 4, 0, 6, sorry. And up 2 over 1, the point right here should have been negative 1, 8. So, and this one's I think a greater than or equal to, so it's a solid dot. So it's going to go like this. And now let's try 0, 0 into the equation. Now I can't see my equations very well, but I could use this one right here for now. I usually go back to original, but since I can't see it, I'm going to use this one. 0 is greater than or equal to, 0 minus 1 is 1. Negative 1, absolute value is 1, times 2 is 2, plus 6. 0 is greater than 6, and that's false. So we want to shade where that's not, so we're going to shade inside this graph. Remember to have arrows at the end of your graphs as you go through these problems. Write an inequality that represents the graph. Well, let's look at this now. Okay, we know why. Okay, let's see the vertex. 1, 2, 3, and down 2. So we know it's 3 over, down 2. Is our slope 1, up 1, over 1. That's good. Now let's try one. Let's say I'm thinking it's going to be greater than. It's not going to be equal to because it's a dotted line. So let's try greater than. Now let's try the point 0, 0. 0 is greater than 0 minus 3 is 3. Negative 3, absolute value is 3 minus 2 is 1. 0 is greater than 1 is false, so we shade the inside. So that would be the great answer there. That finishes off this section.